volume is okay? My volume is okay or low? Someone is writing low.
Volume is a bit low, sir.
A bit low. Okay. This is the maximum volume that I can do. Now it is okay? Now okay?
Yes, sir. Yes, sir. We can continue.
Okay, okay. So, okay, so today, as we know, we will learn something or about the linear regression analysis, multivariable linear regression analysis, logistic regression analysis, and multivariable logistic regression analysis. This is the topic, and we will do some hands-on work also using the SPSS software with the available data set, so that this thing will become clear to you. So now, before going to the regression analysis, the one question is very much common. I ask to my students, do you know about the types of the data? I have also covered this parametric test. So just for the recap from the participant, do you know what types of the data I have told in the previous class?
Yes, sir.
Categorical, continuous.
Continuous and categorical.
Okay, very nice. So those who have not attended, they have to know that two types of the data is we uses in the statistics, categorical and continuous. Categorical data means we are category the information in the category, yes, no format, like male, female, disease, yes, no, recovered, not recovered. These are the thing where the limited category data we are collecting. This type of the data is categorical data, and the continuous data where we are collecting the numerical value, exact numerical value like age, BMI, or and often the continuous variable have the units. Why I am telling you this thing? Because for the learning the regression analysis, types of data information should be clear to everyone. Because if this thing you have doubt in this thing, then it will be very much problem. We cannot learn the regression analysis. So this thing I'm to have the idea about that. So there are some examples. So I think from the participants, this thing is already done. Just for the recap, age less than 50 and more than equal to 50. Categorical or continuous? What type of the data it is?
Categorical.
Categorical.
Categorical. And age years.
Continuous.
Continuous.
And total glucose level?
Continuous.
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 TLC count?
Continuous.
Continuous.
Okay. Recovered, not recovered?
Categorical.
Categorical.
Total cholesterol level?
Continuous.
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 A1C level?
Continuous.
Vegetarian and non-vegetarian?
Categorical.
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 So all students know. So this thing is very important. If you don't know this thing, then very difficult to learn the regression analysis. So this thing should be clear. Two type of the data is being uses in the doing the regression analysis. So those who are please mute. Who are speaking, no, please mute.
यूज करते रही साइज कर रखा जिनसे मतलब हमारे
Sir, can we mute all the participants so that if the participants want to, they can write in the chat box. So participants, you can write in the chat box. If you want to respond something, please write in the chat box.
Am I audible, no?
Yes, yes, sir.
Okay. So before going to the regression analysis, the first step is the correlation analysis. Correlation, participant, you know why we do the correlation analysis? What information we gather if we do the correlation analysis? Yes, please tell. Someone are writing yes. To know the association, to see if the variables are related. How many variables are related? Direction of association, linear association between two variables, strength of association, two or more, relation between two variables. Relation between two variables. Yes, no, because we should be very much specific. Relationship between variables. How much unit change in one variable? No, this one we cannot do this from the correlation analysis. How much unit change, other variable are changing, that will come from the regression analysis. So correlation only for the correlation, to know if one variable is increasing, what other variable is having, whether that variable is also increasing or not. Suppose if age is increasing, weight is also increasing. Suppose this type of the association we want to know, then we do the correlation analysis. And correlation analysis is two types. Do you know what types of the correlation analysis we do? Yes, please tell. Who are telling yes? Please write. One is writing Pearson and Spearman. Okay. So, okay, Pearson and Spearman, at least these are the very commonly used regression analysis. Kendall, Tao, yes. So, two regression analysis, which is very commonly used in our biological data analysis, which is Spearman analysis, which we do for the non-parametric data, where they do the correlation with the rank. And Pearson correlation analysis, where when the data is normally distributed, representative, then we do the Pearson correlation analysis. So what are the interpretation for the correlation? If there is no correlation, then we will get the zero row factor or correlation coefficient, we will get 0. And if it is perfect negative correlation, then we will get -1. And if it is perfect positive correlation, then we will get +1. So correlation value will range from -1 to +1. -1 is perfect negative correlation and +1 is perfect positive correlation. And no correlation, we will get value 0. Why my slide is not moving? So in SPSS, if you want to do the correlation analysis, we can do this. But this type of the graph you will get if there is positive correlation. Like here you see, the example is systolic blood pressure in the y-axis and diastolic blood pressure in the x-axis. And if diastolic blood pressure is increasing, the other systolic blood pressure is also increasing. So now you see, this type of the graph you will get for the positive correlation. And what about for the negative correlation? Just see, in the y-axis, total marks obtained in the school, and in the x-axis, Facebook time. So what it represents, if the time spending in the Facebook is more or higher, it is increasing, the marks is decreasing. So there is negative correlation. Means what? If one variable is increasing, other is decreasing. So this type of the correlation, we will tell the negative correlation. So SPSS we will do the practice when we go to the data. Now we come to the regression analysis. So like one student have told, 1 unit change in the one variable, what is the other variable is changing. So this information we will get in the regression analysis. So in any student want to add something about the regression analysis? What do you have the idea about that? Can we unmute the participants? Want to listen something? What participants are thinking about the regression analysis? What they know? Can we prediction? Someone are writing. Yes, very nice. Regression to know the influence of the one variable on others. Used for prediction. Correlation gives direction and regression gives. Both the variable are continuous. No, that thing I will come later. Depending on the what type of the variable we do, what type of the regression that I will come later. But what do you understand with regression? To see the fitting of the equation to some error, prediction of variables, how independent variable affect the dependent variable. Yeah, unit change in the either direction. Yeah, many one of you are writing very correctly. To just make it simple, I would like to tell you in the correlation analysis, what information we were getting? We were getting that correlation only. One variable is changing, whether other variable are changing or not, or changing in which type of the direction, whether positive direction or the negative direction. What you have seen in the graph, what I have shown you. But now in the correlation analysis is not very much, we cannot know the causal association, we can say that. It may be the spurious association we will get in the correlation analysis. It may be due to some other factor, like maybe increase in the rain and the sales of the vegetable in the day, increase in the rain in the Chennai may be correlated with the sales of the vegetable in the Delhi, maybe. We don't know. But these factors may or may not be related with each other, even though we may get the association in the correlation analysis. So what does this mean? So both the variables are completely independent, even though we can get the correlation, because these are not the causal association we cannot get from the correlation analysis, isn't it? But when you do the regression analysis, what information we can able to get it? Yes, if one variable is changing, what are the effect on the other variable? Whether due to this variable only other variable are changing or not, that information we can able to get from the regression analysis. So correlation analysis is preliminary analysis. We can have some idea about the association between the two variables, but the real association between the variables, if one variable is completely dependent to the other, or one variable is influencing the other variable, that information we can get only from the regression analysis. So it relates the dependent variable to one or more independent explanatory variables. So now here terms came, dependent and independent. So anyone have the idea what is dependent variable and what is independent variable? Someone is writing dependent is outcome variable. Dependent variable is changing due to independent variable. So anyone can give the example in some real biological practice where one variable is dependent and independent to make it simple. You are writing very correctly. So any example in a very simple example, anyone? Age is independent variable, diabetes is dependent. Smoking and lung cancer. Diabetes on obesity, lung cancer dependent. Coffee and sleep. Demand and supply, cholesterol and obesity. Okay, so you are writing the name. But so age is independent variable and blood pressure is dependent variable. Okay. So anyway, you are writing very correctly. But to make it simple, further simple, I would like to add anywhere, whenever we want to know the association, there will be dependent and independent variable. And dependent variable means from the name only it will depend. It depend on something. Like make it simple. If you want to have the example, suppose you want to glow a bulb in your room, but if you press the switch from the switchboard, then the bulb will glow. Okay. So glowing bulb is the dependent on what? Pressing the switch. If someone will press only, then only bulb will glow. Otherwise, difficult to type. So we can unmute also. I request organizer unmute if they want to speak. So, what I told you, glowing bulb, if the bulb is glowing, that is dependent upon the pressing of switch. So any example, any association you want to know in a hypothesis testing, whether it is from the plant science or animal science or the health research, there will be dependent and independent variable. It means, and there is also a term used, outcome variable or exposure variable. So outcome variable will always be the dependent variable because outcome will depend on the some variable. Like an example, like hypertension increases the risk of heart disease, suppose. So what is happening here? Hypertension, it is a disease. Heart disease is a disease, okay? So when the heart disease will come, so heart disease will depend on what? Heart disease will depend on the hypertension. So heart disease is depending on the hypertension. If there will be hypertension, then only heart disease will happen. Then heart disease is the outcome variable, and outcome variable will always be the dependent variable, and the hypertension is the independent variable. So similarly, like the pressing the bulb, pressing the switch, glowing the bulb. So any input variable will be the independent variable, or any output variables. Output is coming from the input will be the dependent variable. So in this way, you will have to identify that which one is dependent variable and which one is the independent variable. Why I am making it more emphasis on this? Because doing the regression analysis using any software, not only SPSS, you need to know which one is dependent, which are the independent. Why? Because software will ask you to select the variable in the dependent list, which are dependent variable, and the independent variable in the independent variable list. So now you see, it relates the dependent variable to one or more independent explanatory variables. So dependent variable will be one, and it will be depend on the many explanatory variable. Like in our example, hypertension and the heart disease. Heart disease is the dependent variable depending on the hypertension. It may also depend on the diabetes. Diabetes is also a factor, causal factor for the heart disease, or some other variable, BMI or any other variable. But dependent variable is only one. What is? Heart disease. So similarly, you will have to identify whenever you're doing your hypothesis testing, which one is dependent and which one is the independent variable. So now, whether changes observed in the dependent variable are associated with change in one or more explanatory variable. So explanatory variable can also be called the independent variable. So dependent variable will be one. Now you see, when we use the regression, we use for the prediction. If suppose some example in a hospital setting, a patient who are admitting to the critical care unit, and suppose we want to assess the severity at the baseline using some scale or some biomarker, or we want to predict the outcome, which patient will recover or which patient will not recover. So the variable, the scale done for predicting the outcome, recovery or not recovery, recovery and not recovery will be the variable, outcome variable, and the scale what you have used is the independent variable. So predicting the outcome. So any future thing you want to predict, you will use the regression analysis. So regression analysis is using for the prediction and for the explanation. Why one variable is changing with the other variable. So the explanation, if you want to know, we can get the information from the regression analysis. So,
Excuse
why-
me, sir.
yes, please.
Sir, in last slide, there is written that one independent variable and one and more independent variable.
Yes.
So in regression analysis, we use one independent variable and one and more dependent variable. Am I right?
No. In the regression analysis, dependent variable will be one only, isn't it? Suppose dependent variable is what? Outcome variable, from where outcome is coming. Okay. Like the pressing the switch is the independent and glowing bulb is the dependent. The glowing bulb is depending on the pressing the switch. The other example is diabetes is the risk factor for the heart disease. Then heart disease is depending on what? Diabetes, isn't it?
Yes, sir.
Heart disease is the dependent variable. So our complete focus will be where to know what are the factors associated with the heart disease, isn't it?
Yes,
So
sir.
we want to know why heart disease are happening, whether it is due to the diabetes, whether it is due to the smoking, whether it is due to the hypertension or BMI, whatever the variable. So dependent variable will be only one, okay? And it
Okay,
independent
sir.
or explanatory variable will be many, isn't it?
Okay, sir.
Getting my point?
Yes, sir.
And the regression analysis is not only giving you only one by one association. It means one independent variable or explanatory variable to the one dependent variable. It will give the many explanatory variable association with only one dependent variable. It means the dependent variable is depending on how many explanatory variable. It may be one, it may be two, it may be three factors are combining together and causing the outcome or causing the problem. So all these information we can obtain from the regression analysis. Is it clear to all? Is it clear?
Yes, sir.
Yes,
Okay.
sir. Please give one example,
Hello?
considering one dependent variable and three variables.
Yes.
Please give one example, sir. One is dependent variable and independent variable is more than.
Okay. Example you want me to give? Example?
Yes, sir. Yes, sir.
Okay. So let us take an example in the hospital setup. Okay. So there is a critical care unit or the trauma center where the patient who get the accident, okay, and they are getting admitted. Okay. Suppose this is the example. Patients are getting admitted in the trauma center and we want to know the mortality. Okay. Which factor are predicting the mortality? Okay. So which is the dependent variable in this case? Example.
Mortality.
Mortality.
Mortality we want to predict. Then mortality is only one variable, whether patient will die or do not die. This is the only situation will happen, isn't it?
Yes.
So
Yes,
dependent
sir.
variable
Yes.
is only one. Our entire focus for testing the hypothesis will be what are the factors which can help us to predict the mortality. Okay. So now what are the factors will come? It may be the age. Age could be the factor, isn't it? Age is the independent variable. Maybe higher age people will often die more. That could be the case, isn't it?
Right.
Other variable could be severity of the accident. If the very severe accident had happened, the chances for the mortality will be more. So it may depend on the both the age and the severity of the accident. It may be the other variable like the other comorbid condition. It may be the diabetes may also increases the chances for the mortality, increases the chances, or any more variable, explanatory variable. Whenever we do the regression analysis, so all these variable, independent or explanatory variable influence on the dependent variable, we can able to know in the regression analysis. Is this point is clear?
Yes, sir.
Sir,
Yes, sir. Clear.
is it that while prediction that it should be categorical prediction? Because suppose we are using some medicine for diabetes and my outcome is sugar level, then can it be sugar is independent variable and we try to find out relation between other factors?
That I will cover in the next slide. Okay. You are telling ki if the outcome variable is continuous, then what type of no? So there are two types of the regression. I will come later in the next slide. Okay.
Okay, sir, no problem.
Sir, is there any difference between covariate and independent variable?
Covariate and independent variable, no, not much difference. Okay.
Okay, sir.
Sir, I have a doubt.
Yes, yes.
Sir, if I want to study a relationship between work-life balance and job satisfaction, I
Okay.
want to draw a conclusion, so what type of analysis should I use?
Job satisfaction, what type of the variable it is? Continuous or categorical?
Hello?
So job satisfaction is which type of the variable? Continuous or categorical?
Categorical.
Hello?
Categorical. Yes.
Categorical, sir. Categorical.
So job satisfaction where there will be yes or no. Only we have two options. So categorical variable, isn't it?
Yes, sir.
So your outcome variable is categorical. Okay. So any student
sir.
know our outcome variable is categorical, then what type of the regression we do?
Chi-square.
Logistic.
We can plot job
The chi-square, sir. Work-life balance and work-life balance and the job satisfaction both are categorical. So we would rather do chi-square.
Job logistic regression, logistic.
But I am telling you, no, chi-square will give you the information about the one by one only, isn't it? So chi-square
Yes, sir.
chi-square have the limitation. It will give
Logistic regression. Logistic.
logistic regression. Yes, regression is what regression are doing. Regression is not only doing one by one association, isn't it? There are many factors, many explanatory variable may be associated with the outcome variable. Like the job satisfaction may be associated with the other variable also, age also, their salary also, many factors. So regression analysis can handle all this information. It can gather all the information. But in the
Sir,
yes,
I want
yes,
to ask one question, sir.
yes.
Sir, kindly just after completion, just how many there are multiple variables are there, independent variables. What is the
Okay.
criteria of selecting the variables? Sometimes what happens when we add one variable, the analysis result change. When we remove that particular variable, results become significant. Once we add it, then it becomes non-significant. So what is the criteria of selecting the variables for independent variables, sir?
Yes, I will come at the last because these were.
Sir, thank you, sir. Thank you.
At the last. Okay. Yes. So now in the SPSS, whenever you go, it will ask you which are the dependent variable and which are the independent variable. I hope this thing is clear to all so that you can able to select the variable in the SPSS. So dependent variable, as I told you, it is the output variable, the output, and the independent variable is the input variable from the which are responsible for giving the outcome. So now this is the smoking is the risk factor for the heart disease. Find out the independent and dependent variable.
Smoking
Heart
independent.
disease is dependent.
Heart disease is
Smoking is
dependent. Smoking is independent.
Yes, because heart disease is depending on the smoking. If the person will do the smoke, then heart disease will happen. The outcome will happen. If no, then there is no heart disease. This type of the scenario will come. So now there will be some other name also. Whenever you go to the other software, whenever you read the statistical books, there will be some other name will also you will encounter. So you need not to confuse. They are the synonym for the dependent and the independent variable. Like the independent variable, the variable that is presumed cause of some effect. Okay, that is the independent variable, and it is also called exposure variable. Somewhere it will maybe written that exposure variable, the independent variable, or the predictor variable. Predictor, some published paper you will read, these are the predictor for the outcome. Somewhere it may be written the input or the explanatory variable. You need not to confuse, these all are the same. All are the same, independent variable. And what are the dependent variable? The variable that is presumed effect of the independent variable, also called outcome or response variable. Okay, so outcome variable we can say. And there will be other type of the variable which is called extraneous confounding variable. Anyone know what is confounding variable?
Yes, sir.
Yes, sir.
Yes, sir.
Confounding variable is not
Please tell, please.
studied, but it will affect the outcome.
It will affect the outcome.
जो इंडिपेंडेंट और डिपेंडेंट के बीच में जो आता है वो कंफाउंडिंग होता है सर.
Sir, confounding factor affect both outcome and exposure, sir.
Sir, we are not able to hear you.
Yeah, now I'm audible, no?
Yes, sir.
Yes, sir.
So आप बोल रहे हैं कि बीच में जो आता है वही कंफाउंडिंग वेरिएबल है.
Sir,
मतलब जो
confounding
आउटकम को
variable,
इफेक्ट करता है, जो
sir,
आउटकम को इफेक्ट करता
outcome
है,
exposure
उसको
दोनों
बोलते
पे
हैं.
सर
affect
जो
करता है.
वेरिएबल हम लोग के स्टडी का पार्ट नहीं है और हम लोग के आउटकम को इफेक्ट करता है वो हम लोग का कंफाउंडिंग वेरिएबल है.
यस सर, जिसके इफेक्ट को हम लोग शायद नेग्लिजिबल काउंट करते हैं या फिर
That only affect the
Sir.
outcome variable.
सर इंडिपेंडेंट वेरिएबल के साथ मिलके जो
Yeah, you are very correctly telling. So any other opinion?
Sir,
इंडिपेंडेंट
for
वेरिएबल
example, in
Sir,
smoking and oral
non-uniformly
cancer,
distributed होता
if
है
we
ये.
see alcohol,
इंडिपेंडेंट वेरिएबल
कोई
के
एक बात करो
प्रभाव
यार,
को
कोई एक
प्रभावित
बात कर लो.
करता है, जिसकी वजह से डिपेंडेंट वेरिएबल पे उसका प्रभाव इंडिपेंडेंट वेरिएबल का जो प्रभाव दिखना चाहिए वो प्रभावित कर देता है, उसे कंफाउंडिंग वेरिएबल कहते हैं.
Okay. So you have very correctly idea what you are telling. So anything which are disturbing, isn't it? What the information we wanted to know, the association or causal association, if it is getting disturbed, isn't it?
Yes.
Then so we can call it as a confounding variable. Is it okay?
Yes, sir.
So it will affect both the exposure and both the outcome. Okay. And due to the confounding, there are
is a third variable.
We cannot call it as a bad variable, but
Third
variable. Yes, third variable.
Independent and dependent variable or confounding variable is a third variable, which affect both independent and dependent variable both.
हाँ जी.
Yes, it will affect both the independent and dependent variable. Very correctly you are telling.
Hello,
So,
sir.
Yes, please.
Sir, I have a question. Please try to explain this confounding variable with some examples so that we'll have a clarity.
Yes, that is I wanted to do this. Okay.
Yes, sir. Yes,
So
sir.
the
Thank you, sir.
example, suppose we take an example. We get the some analysis someone has done, and what they found that coffee drinking is the risk factor for the heart attack. Okay. Or we can say heart disease. The lots of the coffee drinkers, what they got in the analysis, and they got the heart disease is more among them. So people started worrying what it has happened. How the coffee have the association with the heart disease? Anyone is having the coffee. So there might be some error in the analysis or what. Then people are trying to get that information. Then they did the analysis. They also found the smoking is also a risk factor for the heart disease. Okay. So now anyone can know why so coffee is also giving treating as a risk factor for the heart disease. Anyone have the idea?
So
Yes, sir.
कॉफी के अलावा और भी कुछ हो सकता
Coffee, they are taking cigarette.
Drinker are also a smoker.
Coffee drinker are also a smoker.
Also a smoker.
After the smoking, if you see, or after the coffee, people used to smoke, isn't it? You can see in the Nescafe or many places. So people have the habit. Coffee and smoking, they take both the thing together. So what had happened? So the real risk factor is what? Real risk factor.
Smoking.
Real risk factor was the smoker, but all the smokers are also having the coffee. Coffee is also, because this is also present in the all smokers. But in real, the smoking is the risk factor for the heart disease. So in this case, coffee is what? Coffee was treating as a confounding variable. Okay. So coffee is not the real factor. So any factor which is disturbing the association, if it is influencing both on exposure and both the outcome anywhere, then we can call this type of the variable is called a confounding variable. It means distorting the effect, isn't it? Our aim is to know the risk factor, what we wanted to test, whether it is risk factor for the outcome or not. Our aim was to know whether smoking is the risk factor for the heart disease, isn't it? So in this association, how many variables are affecting? These variables can be treated as the confounding variable, and the regression analysis give you the opportunity to nullify the effect of the confounding variable, to know the independent effect of the variable, independent effect of the exposure variable to the outcome. That information we can get it from the regression analysis. Is it clear what is confounding variable?
Yes, sir.
Yes, sir.
Okay.
Yes, sir, it's clear.
Okay, so variable for the analysis, high body weight is associated with high systolic blood pressure. Which one is dependent?
Sir, systolic blood pressure is a
Systolic
dependent
blood
and
pressure.
High
Body
body
weight
high
is
body
independent.
independent variable.
high body weight is dependent on the systolic blood pressure.
Blood
Hanji.
pressure is dependent variable.
Dependent is high body weight.
High body weight is independent.
High
Sir,
body
there
weight
is
is
no
independent.
independent
Independent.
variable.
Systolic blood pressure is dependent.
So there are controversy. Why it is happening? Which one? Someone are telling high body weight, someone are telling systolic blood pressure.
So body weight is independent and systolic is dependent, sir.
So body weight is
Body
independent.
weight, independent variable.
Body weight is independent variable, isn't it?
Okay.
Hanji.
Just you see, systolic blood pressure, we want to know from which variable systolic blood pressure is increasing. So systolic blood pressure will depend on the body weight. Okay. So body weight is the independent variable. Is it clear to all?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Now in this case, which one is dependent, which one is independent? Age is associated with duration of stay in the hospital after surgery.
Age is
Sir, age is
independent and duration of stay is dependent.
Dependent.
Yes.
Age is dependent or independent?
Independent.
Age is independent. Age is independent.
Independent and the hospital stay is depending, isn't it?
Dependent. Hanji.
How many days they stay in the hospital, that is depending on the age. Age is the independent variable. Is it clear to all or any confusion?
Yes, sir.
नहीं sir, सब clear.
Clear है sir.
पूरा
कुछ
clear
clear
है
है sir.
Good.
पूरा clear है sir.
ठीक है, चलिए बहुत अच्छा, क्लियर है तो. Now we come to the types of the regression analysis. When we use the regression model, just in the left hand side, what you are seeing, one explanatory variable, that is called simple regression analysis. It means dependent variable will be one only and the independent variable is also one explanatory variable. Then this type of the regression is called simple regression analysis, and the simple regression analysis is divided into two types, linear and logistic. Anyone knows when what is the linear and what is logistic?
Yes sir.
Linear
So
is
linear मतलब एक dependent और एक independent. Logistic is
so
one
linear
or more.
means linear means continuous.
नहीं, linear में एक independent और एक dependent होता है.
Dependent is affected by only one factor, and we can get a linear scale. If we x and y, will get a simple equation.
When the proportion between dependent and independent variable is same, then we will getting a linear. It is a straight line. And in logistic, we are getting a curve.
In the logistic, what we get?
the
we are
logistics,
we are getting a curvilinear, means we are getting a non-linear equation.
in logistics, our response variable is binary, is no type.
Response variable is binary. है ना?
Yes, sir.
Response variable means you mean to say outcome variable, isn't it?
Yes, sir.
Yes, sir.
So, okay, here we are taking the independent and dependent variable.
Okay.
Dependent variable is which type it is? Binary or?
Binary. Binary, sir.
Okay, binary. So just what she is telling, if the outcome variable or dependent variable is binary. So any example you would like to give where it will fit in this?
Yes or no? Disease, no disease.
So any example you give? No. Where we will apply the?
ये crowd actually.
So बहुत सारे हो सकते हैं सर. Independent में
एक एग्जांपल आप बताइए ना, बहुत सारे हो सकते हैं.
Diabetic,
Hypertension and low hypertension.
एज वेट BMI इन सब में डायबिटीज होती है नहीं होती? यस और नो?
Crop depends on rainfall.
Which thing? Crop depend on?
Rainfall.
Sir,
Any other-
mortality rate, infant mortality rate, sir, neonatal mortality rate in the logistics are dependent variable.
And what are the independent variable in this case?
Sir, age factor.
Age. Okay. So age is associated with infant mortality. Any other example? Some simple example where we apply the logistic regression?
Sir, a customer buying a product, whether it's yes or no, depending on various factors.
Yes, that's the right answer. हाँ सर, मार्केट रिसर्च के लिए यूज करते हैं. मार्केट रिसर्च
नहीं, मार्केट रिसर्च के लिए नहीं, मतलब किसी भी रिसर्च के लिए कर सकते हैं, बट इट विल completely depend on the outcome and the outcome variable and exposure variable, or dependent and the independent variable. Like we already know, she told that the outcome variable should be binary. Okay, if the binary, then we will apply logistic regression analysis. Outcome variable binary means yes, no, disease, yes or no, satisfied, no satisfied, like this type of the recovered, not recovered. Okay, if this type of the outcome variable, to predict this type of the outcome variable, we will use logistic regression analysis. Okay, now the example would be, suppose smoking is the risk factor for the heart disease. Okay, now you see heart disease, which type of the variable here?
Dependent.
Binary variable. Dependent variable is binary, whether heart disease will be present or heart disease will be absent, isn't it?
Yes, sir.
So we have only two options to predict this type of the outcome variable. We will use logistic regression analysis. Okay,
हाँ सर.
clear? And when, give me example for the linear regression.
So 1 to 1, sir. One dependent and one independent.
So dependent variable is which type?
It is metric. Always it is metric.
Metric means?
Continuous data.
Continuous, sir.
Continuous, no? So we are giving you the name for the continuous or categorical, then this name we will use, okay, for practice. So if we want to predict the numeric dependent variable or continuous dependent variable, we will use linear regression analysis. So anyone would like to give an example where we apply the linear regression?
Blood sugar and diabetes.
Blood sugar and diabetes, is it okay? What other students are telling? Is it okay or it is not okay?
Not okay, sir.
Not okay.
Not okay. Not
Right,
okay.
depends on many of things.
Where are the numbers?
Yeah.
Age and height, sir.
Age and height. Okay. So which one is dependent?
Height
Age is independent. Height is dependent.
Height is dependent. Okay.
Height is a response variable.
Okay. Okay. Acha, in any case, age can be dependent variable. Is it possible? What do you think?
No, sir.
Age cannot be depending on, no, it will be growing, it will go only, isn't it?
Age dependent on the nutrition.
Age dependent on nutrition, is it correct answer? What
No,
other
No,
Yes,
sir.
sir.
No, sir.
No.
Whether we'll get the nutrition or not, age will increase.
Weight and height are dependent on nutrition, but not the age.
So it will not only know all the continuous variable you can predict. You cannot predict the age, isn't it?
Age and time, sir.
So age cannot be dependent on any variable. It will be only SO independent variable. Okay.
Age is always an independent. Okay, sir.
Is it correct? No.
Aging look.
Age looks like depend on nutrition. No. It cannot depend on nutrition.
Sir,
Whether
in forensic studies, like when we are estimating age with the bone structures and density of the bone, can it be called as dependent variable?
That is a very different scenario. No, that is very different scenario. You are only predicting the age based on some marker, isn't it? In the forensic study. In that case, it may be for the model build-up. Suppose you want to know, you are predicting age only based on some marker, isn't it? So that is a different scenario. But I'm telling you for the real things, like here in this case, what is she writing nutrition? Age is depending on the nutrition. But it is not possible, no. न्यूट्रिशन से एज कभी डिपेंड नहीं करेगा ना, वो तो एज बढ़ेगा ही बढ़ेगा हमेशा, हर समय हम लोग का एज बढ़ रहा है, isn't it?
Yes.
It is not depending on, कल हम लोग एक दिन और बड़े हो जाएंगे.
Oh, of course, right, sir.
So now age depends on time. नहीं, इस तरीके का we cannot predict the age. Okay, ठीक है, इस in the normal scenario time के साथ तो age बढ़ेगा ही बढ़ेगा. Now you see, let us take an example, simple example for the linear regression analysis. Like so, blood glucose level, suppose, okay. The blood glucose level is depending on how many mangoes the people are eating, okay.
Yes.
So blood glucose level is depending on mangoes, isn't it? So people will have the more mangoes, the blood glucose level will be high, isn't it? So suppose we want to predict what are the factors associated for the blood glucose level. So mango could be the one of the factor. There could be other factor also. But blood glucose level is, since it is continuous variable, and we want to predict the continuous variable, dependent variable, we will use linear regression analysis. Okay. So these are the two types of the regression analysis we very commonly use. There are other types also, like some person have told curvy linear and all these things. These are the also type of the regression, but these are the very commonly used. No, for our HSO requirement. For the higher modeling, we will do the curvy linear analysis also, that is different, but these are the commonly used. Now, this is the simple linear regression I am telling you. Now, give me example for the multiple linear regression or multiple regression analysis where 2 plus more than 2 plus explanatory variable is there. Then we will use multiple regression analysis. Any example you would like to give for the multiple linear regression analysis?
So age, height, and all these things depends on BMI.
Blood glucose, mangoes consumption, and sugar consumption. Something like that.
Depend on what?
Where not only mangoes, even sugar also can increase.
So
Coffee and
education,
smoking on hypertension.
So I think you are telling more than two dependent variable. No, there will not be more than two dependent variable. Dependent variable will only be one only. Explanatory variable will be more. Or independent variable will be more. Dependent variable will be only.
Sir, effect of taking green leafy
Sir,
vegetable
independent
and
variable
iron
is one.
folic acid
And dependent
on
variable will be many,
hemoglobin.
right?
Dependent variable will be only one. Okay, in always.
So diabetes depend on
Sir,
the
is it
diabetes
dependent
and
which is
eating the
multiple
blood.
and independent which is multiple?
No, that will be the different regression. But here, what we are giving you, the
Sir,
time.
मैं दे सकता हूँ sir example.
Sir, please give an example, sir, so that we'll all understand.
Yes, yes, I'm giving you just let the
Sir,
student first.
I
Yes,
have one example.
yes,
Predict
yes.
the student performance based on variables such as study hours per week, attendance, previous exam. These are independent variable, and here students' performance will be dependent variable.
Yes, yes, very correctly. There are many.
So I have one more, sir.
Sir, good evening, sir. Just one request, sir. This topic is actually new for most of us, so it'll be really good if you can summarize with explanation, sir,
Yeah, yeah,
for
I'm
us to
giving
understand initially.
just I
Thank you
wanted
so
to know
much.
from the
Yes,
student,
sir.
then definitely.
Instead of
Thank you so
asking
much, sir,
us,
because it
you
is getting
better go
difficult
with
for
your
us.
explanation
Thank you.
and then ask
Hope you
questions
understand. Thank you.
so that it will be helpful, sir. You first explain and then ask questions so that we'll
Yes,
check our understanding. So that would be better, we guess. And it
for
will
most
save,
of us,
it will
this is
also
the
save time.
basic first time we are exposed to this, sir. So just requesting your cooperation.
Okay, no problem. Okay. So
Thank you, sir. Thank
what
you, sir.
I told you, the regression analysis, there are two types, basically simple and multiple. In the simple regression analysis, there will be one explanatory variable and one dependent variable. Dependent variable will be only one. Dependent variable is also called outcome variable or output variable. Like the smoking is the risk factor for heart disease. Heart disease is the dependent variable. It is depending on the smoking. If there is only one explanatory variable, then we use the simple regression analysis. Simple regression analysis are two types, linear and logistic. In the linear, what we do, our dependent or output variable is what nature? It is continuous in nature, the numerical value, like BMI, or we can say blood glucose level, systolic blood pressure, numerical value. If any numerical dependent variable we want to predict, then it is called linear regression. And if we want to predict the binary outcome variable, binary outcome variable means categorical variable, like in example, heart disease. Heart disease we want to predict. What are the factors associated with the heart disease? So heart disease is the binary variable, binary outcome variable. If this type of the variable we want to predict, we will use logistic regression analysis. Okay, and this is the one by one analysis. Only one explanatory variable and one dependent variable. If the other type of the analysis where more than two or more than explanatory, 2 plus explanatory variable, then we will use multiple regression analysis. Now you come to the linear, multiple linear regression analysis. What we do? Dependent variable will be only one, okay? Like blood glucose level. Blood glucose level is depending on how many mangoes is being eaten by the patient or subject, okay? Now, there will be other factor also. The dependent variable is only one, blood glucose level in the subjects. The mangoes eating is the one variable. It may also depend on the other variable like exercise. The people are doing exercise or not. It may also depend on the other comorbid condition like whether hypertension was there or not. It may also depend on the physical activity, whether the person are doing the physical activity or not. So there are many explanatory variable. More than two explanatory variable, we want to know all those association with to the one dependent variable, which is called blood glucose level. If this type of the regression we want to do, then we will use multiple linear regression analysis. Is it clear to all? Multiple linear
Yes, sir.
regression analysis. Now we come to the
I have
multiple.
one doubt.
Yeah, please.
Always independent variable is in the continuous form in linear and multiple linear regression.
No, independent variable can be also categorical, can be continuous. There is no any limitation. Okay, but dependent variable is what type that decide the what type of the regression we will use, whether linear or logistic. If the dependent variable is continuous, then we will use linear regression. If the dependent variable is binary, then we will use logistic regression analysis.
And sir, in logistic regression, have a more than one independent variable.
Yes, more than one independent variable is possible in all the case, isn't it? If we are using the multiple regression analysis, So suppose in the logistic regression analysis example, heart disease, okay? Heart disease is depending on the smoking. So smoking is the explanatory variable for the heart disease. So heart disease may also be depend on the hypertension. Heart disease may also depend on the BMI. Heart disease may also depend on the age. Many variables, isn't it? So many explanatory variable effect on one ASO dependent variable, which is the heart disease. Whether heart disease will be yes or no. If this type of the condition will come, then we will use multiple logistic regression analysis. Is it clear to you?
Yes, sir. And sir, is it
Yes,
possible
can you
the
explain
regression?
Again, multiple logistic regression.
multiple logistic regression? Okay. So outcome variable, I am telling you, for any hypothesis testing, there will be the outcome variable and the exposure variable, or input variable and output variable. Whenever we are doing the hypothesis testing or association, there will be two variable. Is it okay to you? Now these two variable, smoking is the risk factor for heart disease. Okay. Smoking is the risk factor for heart disease. Okay. This is my hypothesis we want to test. So due to smoking, heart disease are happening or not? So heart disease is which type of the variable? Binary or continuous?
Binary.
Binary. Binary.
Binary, whether heart disease will be present or absent. So
Sir,
we
there
want
are issues with your voice, sir.
yes. Is it heart disease is the binary variable? Okay.
Yes, sir.
So binary variable, whether the heart disease will be present or absent, we have only two conditions. So if we want to predict the heart disease, yes, no, and the smoking is the explanatory variable, and there are more explanatory variable. Maybe the hypertension is also causing the heart disease. Okay, there will be age also, maybe the risk factor for the heart disease. There will be gender also, maybe the risk factor for the heart disease. Suppose all these four variable we are having, more than two explanatory variable, all these variable influence on the heart disease. We want to know, we will use multiple linear regression analysis. Okay. The only key important thing in the multiple variable, there will be more than 2 plus explanatory variable in the multiple regression analysis. Outcome variable will be only one in both the cases. The nature of the outcome variable will decide whether we will use linear or logistic. In the linear regression analysis, the output variable or outcome variable is the continuous, numerical, and in the logistic regression analysis, the outcome variable will be binary. Okay, is it clear?
But if there are only two explanatory variables,
Yes, sir.
then what to do?
If there is two explanatory variable, then also we will use multiple regression analysis.
And sir, in both the cases, the independent variables may be continuous or categorical, right?
Yes, right. There is no any boundation key. The independent variable is continuous or categorical. Independent variable could be in any format. Okay.
Yes, sir. Okay.
Because all the variable are important, no. So we cannot also tell that only continuous variable will be there in the logistic or linear regression analysis. Independent variable could be categorical, could be also what? Could be continuous. Even though if you are collecting the ordinal data also, these ordinal data also are part for the independent or explanatory variable. Okay, there is multiple, more than two category also. Suppose the stage of the disease stage 1, 2, 3, 4. If this type of the variable is also there in the independent variable or explanatory variable, these can also we can take in the regression analysis. Okay.
Okay, sir.
Sir, why
Yes, sir.
called as a logistic regression? Logistic.
Why statistician has given this name as a logistic?
Yes, sir.
So the linear, you are knowing the linear relationship is there, that's why it is there. But in the predicting the binary variable, there are log transformation things are required to be done. Okay, so that's why they used to do the logistic regression analysis. Okay, for predicting the binary variable is what? Yes or no format, isn't it? So there is only two possibility, 0 or 1, yes or no. So for knowing only two categories, there are exponential equation need to be done. There are many things in the equation. That's why it is called logistic regression analysis. Okay.
Sir,
Yes.
sir, I have a question, sir.
Yes, please.
Sir, in multiple linear regression, I mean, one more than two or three, more than two will be independent variable, and one will be dependent variable, right, sir?
Yes, always the dependent variable will be one. Okay, always.
Yes, sir. But the independent or dependent variable has to be continuous in nature, right, sir?
No. Only the dependent variable is what type, whether it is continuous or categorical, that decide whether we will use logistic or linear.
Linear.
Yes,
Independent
sir.
variable could be-
Sir, just let me complete first, sir.
Yes,
I'm
yes.
talking about linear regression only, sir.
Yes,
In
yes,
case of
yes.
linear regression, independent and dependent variable has to be continuous in nature. Data has to be. Okay, sir. In logistic regression, independent and dependent variable, dependent variable will always be like categorical in nature, right, sir?
Right.
And independent variable, what will be the independent variable, sir?
It could be
Anytime.
it can
Anytime.
It
be
could be
continuous
anything
anytime.
in any three, anything.
Okay, sir. Thank you, sir.
Even in the linear, you are telling no, the independent variable should be continuous. In the linear also, the independent variable could be binary
be.
or categorical. Okay. So
Yes,
there
sir.
is no any limitation for the independent variable, whether it is continuous or categorical. Okay.
Sir, if
Sir.
dependent variable has more than two categories, then what kind of test we use?
No.
Multinomial.
To avoid alcohol consumption.
Okay.
Sir,
No, you are
Amit
telling
sir.
independent variable is more than one group. That you are telling, no.
So more than two
If
categories.
dependent variable has more than two
No,
categories,
we will use only the linear or logistic regression analysis, where whatever it is, but only thing we need to define the category if you have more than one category in the independent variable. Okay. We have to name it as which one is the reference, like severity of the disease you are putting in an independent variable, and you have to tell which one is the reference. Suppose you want to compare the stage 1 with the stage 2, 3, 4, then one category you have to tell the reference. Okay, so the time is not much, so I have to cover many things, so I have to move forward.
Amit sir, can we take questions? Sir, can we take questions in the last of the session? Session. All the topics.
Yeah,
So
yeah.
I'm just-
We will take more questions. We will take more questions
Please,
when we
please
complete.
write.
Okay.
Please, you can write in the chat box. So I'm just muting all. Okay, so first we cover the session. After that, we take the questions. You can write your questions in the chat box.
No, you can. So you can see this. So what I learned that what the previous participants are asking many questions that in the independent variable, if it is multiple category like so disease stage of the disease 1, 2, 3, 4 in the ordinal nature, then that could be selected as an independent variable. Is not. Yes, we can select this thing as an independent variable or explanatory variable. Only thing we have to tell the software that which one is your reference category, and that reference category, the category will be compared, and it will give you the odds ratio or the beta coefficient for each HESO category compared to your reference category. So this is the regression we will use. There is no any issue. So for the linear equation, if you are doing the linear regression analysis, this will depend on this line equation. This is the, I think we already aware about this HESO equation. The equation of the line, y is the dependent variable in the y-axis. In the x-axis, it is the independent variable, and the line where it is getting cut with the association when we want to do between the two variables, this is called the intercept, and we are getting the slope. Okay, this is the slope, and this is slope. We can say change in the y, m equal to slope, and from this equation y equal to mx plus b. So what information y is the dependent variable? So if we want to predict the dependent variable with this equation, we can easily know what are the change in the independent variable, how much dependent variable is changing. That information we can get it from this regression analysis. So we will see in our next example. So if there is linear regression, dependent variable and independent variable, this type of the line we will get if there is positive association. This is the example. What it will do, they will have, so suppose this is the data for the age and systolic blood pressure. Age is the in the x-axis and the y-axis systolic blood pressure. So what are the association? Every dot is represented every individual data. What are the association between the diabetes, systolic blood pressure and age? So after getting each subject data, it will draw a line of best fit. So it will try to fit a line between the both the variable, so that maximum prediction can be possible. And this is called a scattered plot. This is the positive association we can able to see. So in this line, if you are seeing the every variable will have the some distance from the line of best fit. So in this case, there will be the line which is getting best fit. It will try to minimize the error. Okay. So first line, how much is the distance from the middle line? So every line distance will be calculated. That is to minimize the errors from the dependent variable, and this type of the equation can be formed like the diastolic blood pressure association with the systolic blood pressure. This is the linear relationship, positive relationship, y equal to a plus bx. This equation will be formed. And if it is the negative association like Facebook time and total marks obtained in the school, the negative correlation will happen. In this case, the y equal to a minus bx. So just you see the minus sign is there. So there is correlation is the negative in this case. So linear regression model, relationship between the variable is linear function. Y1 is the dependent or response variable which we want to predict. And this is the intercept where the line is getting cut. This is the population slope. Slope is the beta. Beta we can able to tell us key 1 unit change in the beta can responsible for how much y is changing. That we will see in our next example. And this is the independent variable x1. And E1 is the error, random error. There will be some error. So from this line equation, all the prediction or all the association can be done in this regression analysis. So regression analysis is only the linear regression only we can do when there is linear relationship between the variable. If we are doing the regression analysis, we need to know first the association between the independent and dependent variable is linear or not. If it is quadric relationship like that, if the variable has increased up to some point of the time, after that it is decreasing. If this type of the association is there, we cannot apply the linear regression analysis. In this case, we have to use the different regression analysis, which is called quadric relation analysis. Now question come, when we do the, how to know whether there is linear association or not with the explanatory variable and the dependent variable. So you will have to make the scattered plot. You will have to make the scattered plot for each independent variable, explanatory variable with the dependent variable, so that you can able to identify the association is linear or what type of the relationship. If it is linear, then you can use only the linear regression analysis. So now we will go to the SPSS for the doing the analysis. So this is the example I will, this is the data I have collected. This is the, and you have to, what are the information is there in this data? The duration of hospital stay, age, okay. So what variable I have collected? The we wanted to know hospital stay is depending on what type of the variable. Duration of hospital stay, I think you all aware about that. If the patient will come to the hospital, how many days they stay in a hospital is called duration of hospital stay. Some patient will have to stay more. Some patient will discharge very quickly depending on their recovery. Okay. So this is the data I'm having, duration of the hospital stay. 10, 12, 14, 16, 18, 12, 20. These are in the 2 days gap. And the age of the patient, 50, 51, like that, so on. The gender data is also with us. The TLC count, this is called total leukocyte count, and the systolic blood pressure, this is the data is with us. Now you have to tell me which is the dependent and which one is the independent variable in this case. What is research question? Research question is duration of the hospital stay depend on what factor? The hospital superintendent want to know which patient are staying more in our hospital. So which one is dependent and which one are independent? We wanted to conduct a study. Stay is dependent, rest independent. Duration is, all of you are writing very correct. Duration of hospital stay is dependent, rest all are independent. Okay, our medical superintendent want to know the study. Hospital stay is depending on what? So duration of the hospital stay is dependent variable. Now you have to tell me any equation you can able to make with this example. Why age is taken? Age, yes, age can be factored. Anyone can able to make the equation. Any information you can able to gather it from the red. Yes, if you want to, what information? If you want to predict the duration of the hospital stay with the age, what do you think? Can we predict? No, positive correlation is okay. But if anyone will ask you if the age will be 52, then any information you can able to get from these two variable. 10 दिन रुक रहा है 50 साल एज है, 12 दिन रुक रहा है 51 ईयर एज है, 14 डेज रुक रहा है 52 ईयर एज है. इट इज ओके कि जैसे जैसे एज बढ़ रहा है ड्यूरेशन ऑफ द स्टे बढ़ रहा है, इट इज ओके. बट एनी इक्वेशन यू कैन एबल टू मेक फ्रॉम दिस टू इंक्रीज एज लॉन्गर ड्यूरेशन. ये तो बहुत क्लियर है, हम लोग को पता है कि ये है ऐसा. बट आपको कुछ ये कुछ इक्वेशन बनाने की कोशिश कर रहे हैं. यस y इक्वल टू m प्लस सी. क्या बनाया आपने इक्वेशन? ड्यूरेशन इक्वल टू एज प्लस जेंडर प्लस TLC कॉन्ट. नहीं, इससे तो ठीक है. ये इक्वेशन हम लोग कैसे बनाते हैं वी विल लर्न. बट अभी मुझे एज का बताइए. एज का ड्यूरेशन ऑफ द हॉस्पिटल स्टे के साथ कोई संबंध आप निकाल सक रहे हैं इसमें से? y इक्वल टू mx प्लस सी. हाँ, इसी इक्वेशन में आप बताएं. ड्यूरेशन इक्वल टू a प्लस बी एज. ये तो आपने लिख दिया, बट ऐसा कोई वैल्यू पुट करिए ना जिससे हम प्रिडिक्ट कर पाए एज को. जस्ट यू पुट सम वैल्यू. mx है सो 50 प्लस सी. आप अच्छा ये बताइए, आप लोग ये तो आप लोग सब कुछ बना दे रहे हैं इक्वेशन लिखने के लिए, बट यू आर नॉट राइटिंग एनी वैल्यू. कुछ आपको दिख रहा है कि 50 ईयर एज है तो कितना दिन है बताइए स्टे? 10 है. 51 हुआ तो कितना हुआ? 51 हुआ तो 12 दिन हो गया. तो आपको लग रहा है कि एक दिन बढ़ने से कितना दिन ड्यूरेशन ऑफ द स्टे बढ़ जा रहा है? 2 दिन बढ़ जा रहा है. 2 दिन बढ़ जा रहा है ना? Yes. So everyone, just you see in the in this SO table, every year increase in the 10 equal to, we predict the age and stay. How much stay required for further? Duration equal to 2 into age plus C. Okay, 2 into age plus C. I think it is not very much correct. You are close, but not correct. But you see, if we convert this thing in an equation, regression analysis is also making the equation from this table. Okay, so what equation the regression analysis will do? Let's see. First of all, you will do the scattered plot you will make before doing the regression analysis. Then you will fit a line, you will see, and is the relationship between the variable is there or not, that you will see. And now you see, if you make this equation, okay, duration of hospital stay is minus 90 plus 2 into h. Just you write down in your notebook, okay. Now you see what is happening. If you are making this equation, now you can able to predict. Positive, it is okay. Now you can able to predict. Means what? 1 year increase in the age is associated with 2 days increase in the hospital duration of the stay. In similar way, you have to analyze the regression analysis. What way? Just you see, this is 2 is the beta coefficient here. Y equal to a plus bx, the equation y there. X is the independent variable. So interpretation would be like that. 1 year increase is in the age. 1 year अगर एक साल एज बढ़ जा रहा है, ड्यूरेशन ऑफ द स्टे कितना बढ़ जा रहा है? जो बीटा कोफिशिएंट जितना आपको मिल रहा है, बीटा कोफिशिएंट इज 2. तो 2 days increase in the duration of the hospital stay. So now you note down this equation, and after noting down this equation, can you able to predict? Suppose you go to, we will go to this table. Now you predict. Suppose your age is 58. How many duration can you calculate? If age is 58, how much duration of the stay? Then 26 days. So similarly, for any SO age, you can able to predict the duration of the hospital stay. So similarly, like this equation, what we have made, regression also make the equation for each and every variable, okay? And it can able to predict the outcome. So any age, just if you put that age in this equation can give you the idea, which is the line equation of line, and you can able to predict the any age, the duration of the hospital stay in this way after making this equation. Now we will go to the SPSS and we will see whether how the SPSS are doing it, okay? Is my SPSS file is visible to all? Okay. Now you see the same data we had put in this SPSS. And SPSS, as we all know, anything we want to do, then we will have to go to the analyze. Y90 we take in the equation, sir. So just you see, we have to predict the dependent variable from the independent variable. So there will be some number will come and the line of equation will come. And from that line of the equation, we can predict the dependent variable. Just you see, this was the value from where we can able to predict. So now you see, whenever we do the regression analysis and how the SPSS are doing it, SPSS will also make the equation. You can make this equation by manually it also. The 90 will come, then only you can able to predict it, the line of best fit, so that we can predict the dependent variable. Now in the SPSS, you want to do the regression analysis, you will have to go to the regression. Okay. In the regression, you will have to use linear regression analysis. Okay, linear regression analysis. What we will do, what we will collect in the dependent variable? What do you think? Which duration of stay, age, gender, TLC count, which one? So now you see duration of the hospital stay, we will choose in the dependent variable, and age we will put in the independent variable. Okay. And we will press OK. Now you see, just see the last one. Able to see this? What is the constant or intercept? Minus 90 you are telling me now from where it is coming. What is the value for the constant or intercept in this case? The coefficient value, no, the constant is the intercept here. The minus 90 you are seeing it, no, in this case, beta minus 90. Okay, yes, this is the minus 90. Your SPSS is also giving you the value, and beta coefficient for the age is what? 2. Okay, so we have made the equation. What equation we have made in our earlier case? Minus 90 plus 2 into age. 2 into age. Minus 90, 2 into age. Okay. So what conclusion we have derived? 1 year increase in the age is associated with 2 days increase in the duration of the hospital stay. And the p-value it is not giving because it is very highly significant. We can get the information from the R square. Someone is asking the question also. Why R square is 1? Why R square is 1? Okay, so adjusted is also 1. The R square is giving us the idea about that. How much variation in the dependent variable you can able to know from the dependent variable. In this case, we don't have any confusion. We are 100% sure in this case, isn't it? If the R square is 1, then 100% we are sure we can able to predict the duration of the hospital stay using the age data. Okay. If we are not 100%, then the value will be less. But it is 1. That's why we are 100% sure to predict. It means the R or R square value will tell you how much your model is good to predict the dependent variable. Okay, let us take another example. Let us see. Analyze. Then we go to the regression analysis. Then linear regression analysis. The hospital stay, instead of age, we are selecting the TLC count. TLC count. Okay, and then we are pressing OK. Then you are seeing what is R square in this case? TLC count. It is reduced. It means we are only 98% sure. Okay, 98% we are sure that our model we can able to predict the duration of the hospital stay with the TLC count. So what is the beta coefficient here for the TLC count? Anyone can write the equation with this from the TLC count and the duration of the hospital stay? No, write in the equation y equal to a plus bx. Y is the your duration of the hospital stay. Stay equal to 3 minus, okay, minus 3.02 and plus 2.0. Yes, yes, very correctly. So now you can able to write the equation also very correctly. So in this way, we are doing the what analysis? Regression, linear regression analysis. Now you come to the multiple linear regression analysis. Here it is only one variable, okay? Age and the TLC count. Suppose we want to use the multiple independent variable, then we will go to the regression analysis, then also linear regression analysis. Then we will select multiple independent variable in this case. We can select the TLC, systolic blood pressure also. We can also collect the gender also. Okay, and then we can make a, okay. How gender will affect? Yes, gender will affect the duration of the hospital stay. Maybe male gender will have the more chance to get the admitted, or female gender might have the more chance to get admitted. Duration of the stay. That may decide. How it will decide? That we will know from the analysis whether it is factor or not for the duration of the hospital stay. But we can put the binary variable also in this case. And now our equation is ready. So constant is, the intercept is minus 4.4, TLC count, beta coefficient is 0.02, systolic blood pressure 0.012. This is the beta coefficient. And the gender, it is minus 0.024. These are the beta coefficient. Higher square is the better. Yes, yes. If the R square is the high, then your model is better. You can able to predict more. And 1 is the for perfect fitting. Yes, it is correct. If the R square is 1, then so your model is best fit. Best fit means you are very much sure that from based on your independent variable, you can able to predict your dependent variable. But in the in the biomedical study, R square is 30. It could be depending on so maximum it could be in the biomedical 30. It is not only 30 to 40% only. It may vary depending on how much your independent variable can able to predict your dependent variable. What you are telling 30 to 40%, we may get the 30 to 40% in the maximum cases, but that is the okay for us in the biomedical cases. But if your model is very much correct, you can able to predict 100%. R square is 1. R square 1, we will not going to get it. Okay. If R square is 1, there is no need to do the research. But the 30 to 40% in the psychiatric research, if 30% also they are getting it, that is acceptable for them. Depending on the other type of the clinical requirement or clinical relevance, if the R square is more, they are accepting it. But the one message for you, how much R square is more towards the 1, your model is doing better. Your model is better. It may be in real. No, in real time, I have never seen it 1 actually. This is the hypothetical example. That's why it is giving you 1. But whenever you will do the regression, whenever you will do the what I can say that regression, real regression analysis, it may go around 50% somewhere 60%, many times 20% also. So it will depend on how much you can able to predict your dependent variable. Yes. So now we have completed the linear regression analysis, and we will go to the logistic regression analysis. 30% of the dependent variable is affected by the independent variable. Yes. Well, how much variance you can able to predict in the dependent variable? The literal meaning for that, the variation in the dependent variable is predicted by your model. The R square value will tell you. Okay. Now you see in this case, what is R square? Yes, you can discuss with me after this class. B value is very less, but it is significant. What can I do? Beta value is very less, but significant. What we can, this type of the thing can also be possible, but it will come that the clinical relevance will come. Clinical significance means whether that much change in the independent variable, you can able to predict the dependent variable. Can it is biologically relevant or not? That you have to see it when it is very less, and similarly you have to interpret it. Like the TLC count, what you are seeing it, the beta coefficient value is very less. So if it is very less, then what does this mean? But TLC count, you know, every cells we are taking into the consideration. In that case, what we used to do, we multiply with 100 so that clinical relevance will come. If the TLC count 100 increase, then how much dependent variable is changing? Similarly, we can, our beta will also be increased. Okay. So in this way, we interpreted our beta coefficient if the very less value are coming. So if the numbers are very high, then beta coefficient value will naturally be very less. But in this case, we multiply the number with 100, sometime 200 to know the answer. Now you see what is R square. R square is the amount of variation or change in the dependent variable is explained by the independent variable or the model, that is called the R square. Anyone knows what is the R square? What is the name of the R square? It is called coefficient of determination. Okay. So that thing is important, coefficient of determination, it is called. Now you see in this example, okay, if it is perfectly, you can able to predict the variance in the dependent variable using the independent variable in the regression analysis. R square will be 1. And your equation, line equation will come like this line equation, okay. If your dots are moving here and there, okay, and there are some variation you cannot able to capture. So this type of the graph it is making here, the R square value is 83, 0.83103. It means 83% variation you can able to predict in the dependent variable with the help of the dependent variable. Here you see the dots are very far. So it is 53% only you can able to predict. Your model can able to predict the variance in the dependent variable up to 53%. Here it is 28%. Just you see dots are very much, there are lots of error in the predicting. Lines of best fit are not very good fit. Only 28% we can able to predict. But in some cases, 28% is also very good. In like psychiatric example, what I am telling you, 28% is also acceptable for them because there is huge variation in the psychiatric cases. So it will depend on the clinical scenario and acceptability in terms of the clinical relevance. So now we have already seen one by one analysis is the simple linear regression analysis. And if it is more than one independent variable, then it is multivariable regression analysis. Extension of the simple linear regression analysis to determine the independent effect of the variable for the specific outcome. Just to recap, we use the multiple linear regression analysis or logistic regression analysis to adjust the confounding effect of the variable. Agar we want to adjust the confounding effect, that also we can do with the regression, multiple linear regression or multiple logistic regression analysis to create a predictive model in which the contribution of the various independent variable determined to predict the outcome or dependent variable that we can also do with the regression analysis. To reduce the error or bias in the estimate, we use the regression analysis, prediction or forecasting. For that also, we can use the multiple regression analysis. The equation will be like that for the multiple regression analysis. Y will be only one, as I telling you. Dependent variable will be only one. The response variable, or you can say outcome variable, Y. So beta is the intercept where the line is getting cut in the y-axis. And this is the slope or coefficient, you can say. Beta 1 x1, this is for the one variable, one independent variable. Beta 2 x2, that is for the second independent variable. Plus similarly, and at the last, the error term will come. In this way, we make the equation. The interpretation for the multiple regression analysis would be like that. Suppose x1 we want to interpret it. How much x1 is influencing the y. Okay. So 1 unit change in the x, how much beta we are getting. that much y will change if all other variable we are keeping constant. Like x2 we are keeping constant, x3 we are keeping constant if there are 3 variable, or 4 variable, x4 is constant. Then what are the independent effect of the x1 which are influencing the change of the y? Okay, change in the y that we want to know, keeping all other variable are constant. So that independent effect we can able to get in the multiple regression analysis. Now you see, if this is the output you are getting, how we will make the equation in this case? Y equal to, first we will write intercept or constant, it is 15.3, y equal to minus 15.3, then HbA1c level is 4.3, HbA1c level plus 1.555 gender, okay, and plus 0.03 systolic blood pressure, which is the beta coefficient for the systolic blood pressure, and the error term will also come at the last. So the interpretation, since it is the linear regression analysis, so all the continuous variable you can interpret it very easily. Like in this case, 4.3 HbA1c level means if 1 unit HbA1c level will change, suppose duration of the hospital stay is the outcome here, then 4.3 days increase in the duration of the hospital stay will happen. Okay. Similarly, for the systolic blood pressure is also continuous outcome. We can interpret it in this like that. But here you see, for the binary variable, how we interpret it? Here 1.55 gender is coming. So higher code, if you are giving for the male, if you are coding in the your variable, suppose 0 you are giving for the female, 1 you are giving for the male, this is the code. The higher code is for the 1 is for the male. Then what? How we will interpret it? If male gender will have 1.5 days higher increase in the hospital duration stay compared to the female, if we keeping all other variables are constant. That will be the interpretation for the binary independent variable when you are putting in your regression analysis. So we will have the equation in this. We can also interpret it in this in the multiple regression. Each coefficient is interpreted as the estimated change in the y corresponding to the 1 unit change in the independent variable when all other variables are held constant. This is the interpretation we do. So there are some thing also you need to take care while you are doing the multiple regression analysis. You should avoid the too many variable whenever you are making the models. Too many variable means, suppose you want to predict the predict the heart disease, okay, and by the smoking, diabetes, and all these factors. So too many variables should be avoided. You may collect many variable. If you are putting many variable into your model may get disrupted. So overfitting should be avoided. How much less variable can able to give you the maximum prediction, or we can say maximum R square, that you should use so that the minimum variable can able to predict your outcome variable. It should be more easily understandable also and usable for the person who will use your equation or the so too many variables should be avoided. Overfitting should be avoided when you make the model. Multi-collinearity is the term in the statistics. Whenever you make the model, it should be avoided. Multi-collinearity means correlation between the independent variable. Dependent variable is only one, and what is here in the explanatory variable or the independent variable, what you are telling it, they should not be very much correlated with each other. Suppose let us take an example. The independent variable is BMI, age, and height. So what will happen? From the height and weight, the BMI came, isn't it, from this equation? So you should not keep all these three variables in your model. You should take only one, BMI, because BMI can give the information for the height and weight. Both the thing is there in the BMI. If you put all these three variables in the model, your model will get disrupted because the multi-collinearity or a very high correlation will come among the variable. If the independent variable are very highly correlated with each other, then there will be problem will come for the multi-collinearity. So before doing the regression analysis, you should check the correlation coefficient among all the variable you are planning to enter into the multiple linear or multiple logistic regression analysis. If very highly correlated variable, then what you will do? You have to remove one. You have to select one. Other variables should be removed so that one variable is okay because both the variable are same because much highly correlated. So one variable you should remove, only one variable you should keep so that your model will not get disrupted. So multi-collinearity, correlation among the independent variables should be avoided. And if there is high correlation, one variable should be removed when you are making the model. Okay. So multi-collinearity, someone has asked me in the beginning of this class how to make the model, how the variable will get selected. So to answer this thing, there are many methods. Okay, the stepwise regression method, the backward selection method, forward selection method, the software having it. So what it will give you, if you are putting all the variable which is available in your data set, if you are using the stepwise regression analysis and with some elimination probability you are giving it, SPSS has this facility, then what the software will do, software will automatically select based on their own knowledge which variable is due for making the model. So suppose you have 20 variable, software will give you only 4 variables are relevant. So that these variable you can choose for multiple regression analysis. In this way also we can able to select which variable we can make the model for our final model. Another option would be one by one analysis you can do for the univariate or bivariate analysis. And every variable you should have get the p-value either by chi-square test or the univariate regression analysis. One by one p-value you should see which p-value is significant, the association between the explanatory variable to the dependent variable, and that variable you can keep for making the model. So suppose 20 variable, only 5 variable become significant, and these 5 variable is also clinically relevant also. Or not only the p-value you should see, that 5 variables should also be there, should be some biological relationship between these 5 variable with the dependent variable what you are predicting it. If these all variable have the clinical relevance for predicting the dependent variable or outcome variable, you should keep all those 5 variable. But suppose in the 5 variable you have only 3 variable are important, which have the clinical meaningful with the dependent variable, you should keep only 3 variables. So statistical significance plus clinical relevance, both things should be important while you are making the model. And other thing is the homoscedasticity of the residual or equal variance. The variance should be equally distributed with this line. That also the assumption for the regression analysis that I am not covering it in this class. And each observation is unique. That is also important. Like there should be not key one subject data is entered multiple times. If one sample data should be entered at one time, so each observation should be independent, unique when you are making the model, independent. And predictors are normally distributed that you can able to see it when you make the model. You can do the normality checking and you can have the idea that if the predictors are normally distributed, then your model will be better. So now we come to the binary logistic regression analysis. As we know, outcome variable is binary. Like in our example, what we have seen, heart disease yes or no, that we want to predict with the other variable, whether explanatory variable, whether it is continuous or categorical, does not matter. If this type of the regression we want to do, we will do the logistic regression analysis. Anyone can tell some example for the binary variables? Binary outcome variables? Any outcome variable you can say, which is binary, true, false? Any hypothesis, disease, yes, no, disease, yes? Can you make some example where we apply the fail pass, yes? Can you make an example in hypothesis testing where we apply the logistic regression analysis? Treatment given, not given. No, it is not possible. Treatment given is not given, may be the independent variable. I am telling you, dependent variable should be yes or no format. Yes, dead and alive. Yes, that could be possible for the dependent variable. Yes, dead or alive. Suppose we want to predict the mortality. We want to predict the mortality in a hospital. So whether patient will die or do not die, or what are the factors for this, then we can use the binary variable. Vaccinated and non-unvaccinated. Okay, this could be the independent variable. Okay, vaccination can help to protect from the disease. So effect of workflows environment on job satisfaction. Yes, that can be if the job satisfaction is the yes or no format. Any hospital example anyone can give? Any in the hospital setup? Smoker, non-smoker can be the dependent variable. Anyone can say? No, answer is no. Nilesh, answer is no. Smoker and non-smoker, we cannot be the outcome variable. This can be the independent variable. Time taken use in the social media, heart disease. Yes, this one is the example. Heart disease, yes, no. Smoking. Heart disease, no awareness. Effect of smoking on pancreatic. Vaccination status on COVID death. Yes, vaccination status in the COVID death. Then COVID death is the dependent variable, whether died or not died, and the whether vaccinated or non-vaccinated can be the independent variable. That can be the example. Yes. Regular and irregular MC. Yes, that can be the variable. Yes. Giving antibiotic cure disease or not. Yes. Okay. So now we will go to the SPSS for the example for doing the binary logistic regression analysis. So this is the data for the binary logistic regression analysis. In this first disease, yes or no, okay, and the age factor, disease, yes or no, age, gender, and status. Status is the, I think it is disease, yes or not, status is the smoker or not a smoker. This is the data. Whether 0 represents no smoking, 1 represents the smoking, age is the continuous variable, gender is the 0 female and 1 male. This is the code, and disease 0 and disease no. Disease you can say heart disease support. Okay. If 0 means no heart disease, 1 means heart disease. Now we will do the logistic regression analysis. 2 binary dependent variable. 2 binary dependent variable, then there is different regression analysis, not the binary logistic. Okay. Now we come to the analyze. We will go to the regression analysis. We will go to the binary logistic. Okay. What we will select in the dependent variable? Please tell. Yes, disease or status we can do, but status here, what I told is status is the smoking. So smoking may not depend. No, here the disease we want to predict. So dependent variable is the disease. Okay. Disease we want to predict with the smoking. Okay. Status 1 is smoking or no smoking. Okay. If we are doing the simple logistic regression analysis, we will put only one variable in the covariate. Dependent variable is the disease, heart disease or no heart disease. And then we will have the option where we will get the 95% confidence interval, because CI for the EXB is very important, because for any time regression analysis you are doing, confidence interval is very much important. So let's see, after taking this thing, we will press OK. Then you see, this is the output. At the last table, if you are seeing that status is the smoking, whether smoking yes or no. The beta is 1.3 and EXPB is the odds ratio. Anyone know what is odds ratio? Anyone know what is odds ratio? Whenever you are doing the logistic regression analysis, odds ratio can give us the strength of association, okay? Because we want to know disease among predicted, probability of disease, risk of the disease is 3.8 times higher among the smokers, yes. So anyway, who don't know, for the odds ratio, EXPB here is the odds ratio, which is 3.8 here, and constant is 0.6. So odds ratio give us the information how much, if you are exposed to the risk factor, how many times the probability that you will have the disease or you will have the outcome. Okay. So now, what are the probability for the disease? So disease here is the heart disease. So status smoking is associated with 3.8 times increase in the heart disease. Okay. If the person will smoke, 3.8 times higher probability that the heart disease will come. But you see the 95% confidence interval. Anyone can say the information whether it is statistically significant or not. Not significant. Why it is not significant? One is included. So for those who are not knowing about the odds ratio, just I want to tell, whenever we interpreted the odds ratio for the logistic regression analysis, the higher than 1 represents the risk, lower than 1 odds ratio represents the protective factor for the association with the exposure to the outcome. Now here it is more than 1, 3.8, then definitely it is the risk factor, but we need to know the whether it is significant or not. To know the significant, we need to see the 95% confidence interval. 95% confidence interval is 0.96 to 15.6. So any ratio measure of the outcome, like odds ratio or risk ratio, this 95% confidence interval should not cross the 1. It means in this range of the 95% confidence interval, 1 should not come. 1 should not come. If the 1 is coming, then we will say statistically not significant. Why we say like this? Suppose what we wanted to know in this case, whether the person is smoke or not smoke, the probability for the heart disease will increase or not. Okay. That is our aim to know heart disease whether it will increase or not. So suppose in the smoking, 30% patient will get the heart disease, and no smoker group will also get the 30% of the heart disease. Then we take the ratio measure, 30 divided by 30, what value will come? It will come 1. 1 means null, nothing. So odds ratio 1 means there is no any effect, no any difference between the, no any influence of the exposure with the outcome if the odds ratio is 1. So 1 is the null value whenever we interpreted the odds ratio. Now you see the 95% interval is what information it is giving us? It is giving us if we repeat the experiment for 95 times, the chances for lying the true value in this range. Okay. So in this range, lower confidence interval to upper confidence interval, which is 0.96 to 15.6, the null value 1 is coming. So the value may cross the null value also. The range may also cross the null value. If this thing will happen, then what we will say is statistically not significant. So telling the significant, this confidence interval should not cover the 1. The range of this confidence interval should not cover the 1. If it will cover the 1, then we will say statistically not significant. What is p-value in this case? Anyone know? This significant shows the p-value. What is the p-value for the smoking in this case? 0.056. Is it significant or not? P-value, no, yes, P-value is not significant because it is not less than 0.05. So P-value is also we are seeing not significant, and from the 95% confidence interval, we can able to see there is no significant. So what we can able to interpret is smoking can increase the risk for the heart disease up to 3.8 times, but statistically it is not significant. Statistically non-significant increase in the heart disease among the smoker, but compared to the non-smoker. So statistically it is not significant. Now you see, this is the simple logistic regression analysis. But if we want to do the multiple logistic regression analysis, then we will select more variable in the covariate or the status we have selected. We can select gender, we can select age, and after doing this, we can press OK. How to write the equation? Yes, that we will see. Now you see, this is the multivariable analysis. Okay, suppose for the multiple variable analysis, what I told you, we should do the one by one analysis. We will select only those variables which are turning significant. Okay. If the variable is not binary, if the variable is not binary, only thing you will have to ask the independent or dependent variable. Which variable? If the variable is not binary or it is linear, it is the continuous. If the dependent variable is continuous, only you will use the linear regression analysis. For the independent or explanatory variable, it could be binary, it could be continuous. Okay, in either case, both the cases. But dependent variable is not binary, then you will use linear regression analysis. If dependent variable is binary, yes, no disease. In this case, heart disease, yes or no, we will use logistic regression analysis. Okay. Now you see, everyone we are getting it. Now the smoking is associated with 3.8 times increase in the heart disease. Statistically, it is not significant. Gender, the male gender, the higher code is for the male. Then we will interpret male gender have 2.3 times higher chance for the heart disease compared to the female. But statistically, it is not significant. So do you think, what about age? Anyone can say age is significant or not? What is the range of the confidence interval for the age? What is the range of the confidence interval? So one is coming in between or not? Yes, it crossed the one. If it will cross the one, statistically it is not significant. Just you see what is happening here. P value is also 0.092, which is more than 0.05. So we will tell age is not significant risk factor for the heart disease. In this way, we make the model. What if the female is a risk factor? Female is the risk factor, then also it will, if you are putting the male as a reference, male is the lower category, then also it will give you for the female, whether female is the risk factor or not. Okay. Only thing in the logistic regression analysis, which one you higher category. Okay. If you are giving the higher category for the female, suppose you have coded your data 1 for the female, 0 for the male. So 1 is the higher value, 1 is for the female. So whatever the odds ratio you are getting, if it is more than 1, then you will say female gender is the risk factor for the heart disease. But if you are female, you are is the higher value 0 or 1. Then if it is going toward lower than 1, then you will say female is the protection for the heart disease. In this way, we interpreted the finding. So what way we make the model? So I think time is over, and we'll take some questions. PPT and data set. Yes, in the last class also I will share you the. Please explain the odds ratio and CI. Yes, I will share you. I was traveling, that's why I could not share, but I will share you. Please repeat it. What you want me to repeat? Dr. Anand Bihari. Odds ratio, okay. CI and odds ratio, okay. So odds ratio, what I told you, it is the ratio measure, okay. Equation similar way we will write, similar in equation there is no any way. So now you see odds ratio means it is the ratio measure. Ratio measure in any ratio measure like risk ratio or odds ratio, null value is 1. Okay. So null value is 1 means there is no any difference between the two groups. Okay. No difference. Suppose in the ratio measure 30% patient are having the disease. In the exposure, suppose someone are smoking, smoking is the heart disease, 30% subject were smoker, and control group also 30% were smoker. So if you analyze it, 30 divided by 30, since the amount of exposure is same between the disease and no disease, 30 divided by 30, it will come 1. So 1 is the null value for the odds ratio or any ratio measure. And if odds ratio is 1, then there is no any association of the exposure with the outcome. So 1 is the null value for the any ratio measure. If it is less than 1, then protection, the risk factor or exposure variable is protective. If more than 1, then it is the risk factor. In that way, we analyze the odds ratio. Now you see, suppose the odds ratio are getting 1.5. The interpretation would be that if there is risk factor, then 1.5 times higher chance for the disease if the patient is carrying that risk factor. So that is the interpretation for the odds ratio. But the significance we can able to know from the 95% confidence interval. 95% confidence interval will tell us if we go to the population, the true value, true odds ratio will fall between that range. Okay. So 95% confidence interval in this range, as we know, 95% confidence interval has lower range and upper range. In this range, if the null value is coming, if null value will come, then we will say there is no any difference. Like in the first case, smoking is the risk factor for heart disease, 3.8 times higher chance for the heart disease in the smoker compared to the no smoker. And if we are seeing this confidence interval, 0. If we go to the population, the true odds ratio may fall between 0.81 to the 17.7. It means what? In this range, 0.816 and 17.7, the null value 1 in the ratio measure 1 is coming. If it is crossing the 1 in this range, if in this range 1 is coming, then we will say statistically there is no significance. No significance. Okay. So in this way we analyze or we interpreted the odds ratio. If the null value will not come in this range, then we will say statistically significant. And you can see all the so significant the p-value, none is the significant where the this range is crossing the 1 null value, because in the population the true odds ratio may go to the null value also, isn't it? So in this way we analyze the we interpreted the odds ratio. Any other question? multiple linear regression analysis in spaces. I think I will ask to the organizer, do I have the time or what to do?
So, sir, I think we are running late. So participants, if you want to ask something, then you can ask. Otherwise, we have to wind up.
Explain the multiple logistic regression. So this is the multiple logistic regression analysis where the one dependent variable heart disease and the many 2 plus SO explanatory variables. So this one is the multiple regression. Multinomial left. Multinomial, so we cannot cover in this thing because many multinomial. So many dependent variable is there. If we want to predict, that is bit complex. So this thing is not covered.
Sir, if you have time, we can cover. Otherwise,
any other question?
Hello, sir.
Yes,
If in the logistic regression, response is not binary, if it is categorical more than 2 categories, like if
response means you mean to say outcome variable or explanatory variable?
Outcome variable.
Outcome variable is so more than 2. Okay, 1, 2, 3, like the stage of the disease, isn't it? Stage 1, stage 2, stage 3, stage 4, isn't it? Like that.
Yes,
and you
yes,
want
like
to predict this has so multiple category outcome variable. This is your question?
yeah, this is the question.
Okay, then if this type of the situation will come, then you will have to use the ordinal regression analysis.
Okay,
so this order has so the staging order we want to predict, the ordinal regression will come.
ordinal regression.
Yes, because we want to predict the category. The order you are telling, no, stage 1, stage 2, stage 3, stage 4.
Yes. Can we do it with the SPSS?
Yes, we can do this.
Can you please?
For that, we don't have the data actually for the staging.
Okay.
But you can go to the regression and there is ordinal, isn't it? Regression, ordinal regression.
Okay.
In the dependent variable, you will put that as order category, and here you will put the
factors. Okay. All the independent factors.
Yeah, independent factors.
Okay. Thank you so much, sir.
Sir, how to interpret logistic regression, sir? Actually, we have to see the odds ratio.
The output of the odds ratio, you have to see it. Okay.
Sir, in that case, when the status is something like 0.54, then what will be the interpretation, sir?
0.54, where it is 0.54?
It may be, sir. Here it is 3.8.
Odds ratio is 0.54. You mean to say odds ratio is 0.54?
Yes, sir. Yes.
Then it is in which direction? It is risk or protective?
Risk factor.
No, what I told, if it is more than 1, then it is risk factor. No. If it is less than 1, it means?
Protective factor.
Protective factor. So what he is telling, if he is getting odds ratio 0.54, okay, then you have to minus it with 1. If you 1 minus 0.54, how much it will come? $46, isn't it?
0.46.
Right? 0.46 will come, no, 0.46.
Yes, sir.
0.46. Then you will say, if that factor or exposure is there, then it will 46% protection from that disease or outcome. Suppose there is a healthy lifestyle you are putting in the model for the heart disease. If the odds ratio is you are getting 0.54, then you will say if the healthy lifestyle you are having, then 46% lesser chance for the heart disease. Okay.
So one question. Sir,
Yes.
in this ordinal regression, suppose the dependent variable is ordinal variable, and what is the column for covariates is independent variable, is it? And sir, factors, what do we put usually? If any example can be given.
Factor, suppose you want to know between the male and female differently. Okay. So in that way you can have this.
Sir, one question regarding compounding variable.
Yes, please.
So from beginning we know that there is confounding variables. So how to control them while doing regression analysis, or in the beginning in form of sampling, etc.
Okay, in the beginning you cannot control the confounding. Okay, in the beginning if you want to do, then the matching is the possible. Okay, like so you want to know what are the risk factor for the heart disease. Okay, and the control what you are selecting, so you can select the matched control. Okay, like suppose 50-year age subject and male patient, then if you want to minimize the confounding, then controls would be also from the 50 age and the same gender, and most probably from the same locality also, if the exposure is also important. So in this way you can select the control to minimize the confounding.
Right.
Sir,
Sir,
if
actually,
dependent variable has more than two categories, like type of fuel, like LPG and wood and cow dung, then what kind of regression will apply on that?
Sorry, what is the question?
Sir, suppose dependent variable is type of fuel, like fuel has
type of fuel
used for cooking. Yes.
Okay.
So what kind of regression will apply on that?
So type of fuel, how many category?
So like suppose it has LPG and wood, cow dung, biogas, like that.
So if I told you, if there is more than two category in the dependent variable, and this is not in the ordinal category, like if it is order, like stage 1, 2, 3, we'll do the ordinal regression. But what you are telling, it is not the order, it can be anything. Okay, types of fuel. Okay, then multinomial you will have to do this, multinomial. Or you can do this analysis with the generalized linear modeling also.
Okay.
Sir,
Generalized linear modeling.
Yeah, generalized linear model will come. From this where you can make the model.
Okay, sir. Thank you.
Sir, in the interpretation of the results here, you had spoken about gender.
Here in this one.
Yeah, in this one. Can you tell me, sir, how you had, which statistic you looked at and said we'll say that which is higher? How will we take that?
This one, no,
Whether,
like
gender.
For the gender. Okay. For the gender, what is the odds ratio we are getting?
2.38.
2.38. What is the confidence interval?
It includes 1, which is not significant.
Not significant. Now 2.3 means what? What I told you, the category what you have coded in the data set. Okay. So what you coded, the higher category is for male. Male means number only. 0 is female, 1 is male.
Okay.
If the higher category you have given for the male, okay, then the male are having the 2.3 times higher risk for the heart disease compared to the female. But statistically, it is not significant. Okay.
Yeah, that higher one, sir, with respect to what did you decide?
With respect to the reference. Reference is the female, no?
Okay. Yes. Got it, sir. Sir, also your statistics when you were doing it, what are the other things you had clicked on other than the main covariate? Other than that, statistics you had clicked on, things that we should look into?
Analyze, we have done regression, binary logistic, disease, I have taken in the dependent, covariate, I have taken all these things. What I have taken, no, in the options, no, we have to take the 95% confidence interval. That I have ticked it. CI for the odds ratio. EXP beta is the odds ratio. Okay. Because for the odds ratio, 95% CI is very important. If you are not clicking it in the SPSS, it won't give you the 95% CI. Okay.
Okay, sir. What about linear regression? When you were doing that, what are the things we have to click for statistics and the other options?
For the linear regression, okay. So analyze, regression, linear, dependent. Dependent was what? No. Here age we cannot put in the dependent, although it is continuous variable. We cannot predict the age. But suppose in this case, age is the continuous variable. I am putting it, although age cannot be dependent variable because we cannot predict the age. But for example purpose only I am giving it. And you can put here independent variable anything. And if what statistics you want, you can able to get it from this. Estimate, model fit, R square change many times. You want to make a multiple model, then what are the R square is changing, descriptive statistics. Collinearity, I told you, no, collinearity should not be there when you are making a model. Collinearity means the independent or explanatory variables should not be very much correlated with each other. If it is correlated, then model will be disrupted. So collinearity diagnostic, you can able to do this. So it will come from the variance inflation factor. Time is not here to give all things, but if the variance inflation factor is more than 5, then we will say there is significant collinearity, then we will remove the variable, one variable. Or we see the also correlation coefficient between the two independent variable. If the correlation coefficient is more than 0.70, then we will have to decide to select only one. So these things, you can select it from the options and you press it okay. Suppose you want the plot, then you can have the some plot also from this SPSS. So whatever you want to get the extra information, you can get it from this. And the main important thing, the dependent variable and independent variable you should put in this category and you press the OK. Then also the R square, the beta coefficient, everything will come. From there you will see whether your variable is significantly predicting the outcome or not. So here it is the beta coefficient is 12.6 for the disease. For gender it is minus 0.2. So if the disease will be present, then age will be 12.6 year more. So although it is age we cannot predict, that is for the example purpose only. So in this way interpreted the coefficient. If 1 unit change in the independent variable, how much beta coefficient is there? The outcome variable will change with this. 1 unit change in the independent variable, the outcome variable will change with the beta coefficient, how much you are getting. Okay.
Okay, sir. Thank you.
So one last doubt, sir. In quadratic regression, suppose I want to apply, how do I go about with SPSS? For example, there is a severity of sickness score. The how sick a patient is admitted in the hospital with the hospital duration of hospital stay. So a highly sick patient will die and there will be less duration of stay. Moderate sick will have a more duration of stay, and lowly sick patient will have a low duration of stay. Just an example. So how do we go for analyze and build for quadratic regression?
You mean to say that there are multiple categories in the independent variable, isn't it? And you want to predict the duration of the hospital stay. Is it your question?
Yes, sir. There's a suppose score of sickness is there. We have calculated a score of sickness and we want to calculate the duration of hospital stay, but it is quadratic. The independent variable is kind of quadratic. Means in that graph form. First it goes positive and then it goes negative like that.
Quadratic, if I told you, linear regression, you should have the linear relationship, no?
Yes, sir.
If it is quadratic, then also you cannot also do the linear regression analysis.
Okay.
For that, there are different also regression you will have to do. But
So
if
can
you
we-
but in this case, suppose the duration of the hospital stay, and there are multiple category, and that is have the you want in the categorical format, like the stage of the disease, or any ordinal category, then one group you will have to define the reference category, and from that reference category, every SO category you will get the beta coefficient, and for that category the beta coefficient will be analyzed with the reference what you have given in your equation.
Okay.
Any other question?
Sir. Hello, sir.
Yes, yes.
Sir, suppose one retrospective study, suppose analysis of poisoning in a tertiary care teaching hospital, what statistical analysis should we do, sir?
What is your question?
Analysis of poisoning cases. It is a retrospective study, sir. Already cases done or treated. We have to collect the data from a medical record department, and we will analyze the data, sir.
So it will completely depend on your hypothesis. Know what you want to know. Suppose you want to know what are the risk factor for the poisoning. Okay.
Yes, sir.
So if you have the data with the poisoning, yes or no. Okay. So but you subject have the poisoning cases, no?
Yes, sir. The data has been taken, sir, for 2 years, and 591 data already collected. And
so the patient who are poisoned, no?
yes, sir. Domestic poisons, sir. Some insecticides, pesticides. These are the types of poison.
Then you will use, suppose your hypothesis completely depend on your hypothesis. Suppose you want to know the mortality. What are the factors for the mortality? So
Yes,
which
sir.
poison in the mortality? Then you will use the logistic regression analysis. The outcome variable is binary, and if
Yes,
your
sir.
outcome is continuous, then you will use linear regression analysis.
Okay, okay. Thank you, sir.
Hello, sir.
Yes, yes.
In linear regression, is it possible to have two dependent variables and one independent?
Two dependent variable not possible. Okay. In the simple linear or multiple linear regression analysis, you will have to have only one dependent variable. But in any example you want to give me where you want the predicting the two independent variable? Do you have any example?
Like the patient having BP. BP is depend on the age, and also any other disease and BP, diabetes and BP, both are depending on the age.
Diabetes and BP both are depending on the age. This thing your question you want to know? So
Sorry,
two
sir.
variables.
Two are dependent and one is independent.
Two dependent and one independent.
Huh.
In this case, then you will have to go to the multinomial, no?
Multinomial.
Mm-hmm.
Okay.
But ideally, this type of the analysis is very complex actually. Interpretation is difficult. But in the real practice, ideally, we are interested in the one dependent variable only. Okay. But it is the very much meaningful thing, the two dependent thing you want to predict simultaneously. If the diabetes is also there and heart disease is also there, both the things are there, and you want to predict the outcome, then why not? So if you have the data set, suppose, okay. So the same individual will have the heart disease and the diabetes, isn't it?
Yes,
If this two dependent variable, so all those subjects who are having both the disease will be categorized into the one category. If you are having the two risk factor, diabetes and the heart disease, okay. If you are both the thing, what are the factor is responsible for causing the both the things, isn't it? So there will be one separate category we can able to make where the both the risk factor are present, okay. And if anyone is only one or none is there, we can make the another category, isn't it? Or if it is one is present, suppose only heart disease present or either SO diabetes is present, we can make the another category also. If three categories there, we can do the ordinal regression analysis. And if you are selecting only those subjects, both the risk factor category 1 and none rest, the other is 0, 1. 0, then we can do the binary regression analysis. In that way we can analyze. But if really there are two dependent variables you want to predict, then we'll have to go to the multinomial regression analysis.
Okay.
So, sir, I think we can wind up because the time is running.
Thank you, sir.
So, thank you so much, sir, for your very informative and very interactive session.
Thank you, sir.
Thank you all the participants for active participation and patiently listening. So thank you so much. We'll meet you tomorrow. Thank you, sir. Thank you so much.
Thank you very much for the patience listening.
Thank you. And good night.
Good night.